Okay, class, this is going to be a live spreadsheet build to accompany lecture number 5. This is chapter 9, exercise number 1, the bookcase making problem. One of the things that I tend to like to do is to um, change my column width as soon as I start on a spreadsheet. I feel like the default column width is a little too narrow to type descriptions into. So I'm going to change my column width to 11 width, just to be interesting. And the very first thing we're going to do is we're going to name our tab. So this is chapter 9, exercise 1. This is a video that's designed to accompany lecture number 5. And it's our very first all the way through linear programming example. In this case, we have a production planning problem. And yes, it is shockingly valuable to simply type things like that into your spreadsheet. Now, I'm going to tab back and forth to this particular slide that was in the lecture because it lays out some things and it shows the entire text of the problem from your textbook. So we're going to go back and forth here, make sure my thinking stays clear as I put things together. And I'm going to do this a little bit upside down compared to what we did in the other video, just to show you that this can work really well. So I've got a objective, and I know I want to maximize profit, and I've got some decision variables that is going to be quantity of each type of bookcase. And I've got data table here in terms of the dollar values of those. So I am going to be interested in saying that I've got some bookcases here, and I'm curious to know, so what quantity do I want to make of a standard, a narrow, or a wide bookcase? And one of the things that I like to do is, we already decided in the earlier tab during the lecture that our decision variables are those quantities. So these 3 boxes right here that I just highlighted, that's our decision variables. So one of the things that I like to do is to highlight my decision variables to look very different than the rest of the page, so it's very easy to find. So I'm going to highlight those in yellow, and I'm going to put a bold outline around them. And I am going to start off by formatting these cells. And I'm going to change the number formatting to a number with 1 decimal place, because I'm just kind of curious, make sure I can see it when it's there. Okay, so now I've got this highlighted boxed in area, and I'm going to put some dummy values in there. What if I made 3 standard ones, 4 narrow ones, and 5 wide ones? Okay, that would be the quantities I've got of each. Now, what is my profit per item? Well, I know from looking at my table over here that my profitability is $8, $6, and $10 for each one. 8, 6, and 10. Okay, now I'm going to highlight those 3 cells. I'm going to right click on those cells. I'm going to click Format Cells. Didn't see it there for a second. I'm going to change that to accounting with no decimal places. That's just the formatting that I want to have here. Okay. And that's my profitability. Now, if I want to have my overall profit, I can type, I'm going to put the word profit right here, and I'm going to make it bold, and I'm going to center it. And in this box right here, I am going to put in the formula sum product, and I'm going to multiply the quantity array, 3, 4, 5, times the profit array per item, 8, 6, 10. Close that out, and I get that. Okay. Now again, I want to format this cell. So I'm going to click Format Cell. I want that to be accounting with no decimal places. For the border, I'm going to put a big fat border around the outline. And for a fill, let's do green. I like green. Kind of dark. Let's do a lighter green. There we go. Oh, that'll be easy to spot. So that's my profit that I'm trying to accomplish. So what I've already accomplished here is I know that these are my decision variables. This is what I can change. Okay, so I'm going to go ahead and put that in there. Decision variables. Okay, and then I know, and I'm highlighted this green, and just because I like to do it this way sometimes, I'm going to remind myself, this is my objective. Okay, this is what I'm trying to maximize. Sorry about that. Now, next I've got some data, and that's going to call out some constraints for me as well. Okay, so I'm going to create a section down here. I'm going to just going to skip a row and do a data and constraints. All right. I know, because we did this a minute ago and we thought our way through it, that I have an assembly constraint. I have a trimmer. Well, this is data, assembly data, trimmer data, shaper data. And these are all going to play into some constraints. I know that assembly is 0.4 hours, whether it is standard, narrow, or wide. I'm going to do the Control C and Control V and put these labels down here. Okay. And I'm going to go ahead and highlight this little section, and I'm going to put a grid around it. I'm going to do an all borders just so I can kind of see it here. This is my data table. 0.4 hours of assembly, no matter the size of the bookcase. Trimming is 0.2 hours, 0.4 hours, and 0.6 hours respectively. And then the shaper is 0.6, 0.2, and 0.5 hours respectively. Okay. And now what I have here is a subtotal, a total area. I'm going to put that central, I'm going to center that over the column. And I'm going to do my sum product again. And this time, the quantity that I've chosen, okay, array times the assembly time array. But before I leave off of this, I am going to come in here and make an absolute reference out of that row 7 for my decision variables, so that when I copy it down the page, it won't move. Okay. And I'm going to drag that down and copy it. So now I've got my new numbers. Okay. If I'm wanting to double check things and I'm kind of worried about stuff, I can highlight this one and say, wow, did that really work the way that I wanted it to? Okay. I stopped the video and edited there for a second. I misspoke on something. So we're going to pick it up here and say, hey, I'm kind of curious. Does this formula refer to what I wanted it to? So if I was on my home tab here and I was curious about that, I can click on my formulas and then click trace precedence and see where this 5.1 came from. And you can see it highlights this entire array with an arrow pointing to it, highlights this entire array with an arrow pointing to it. So I'm reasonably comfortable that I got the right stuff that I wanted. Now I can click remove arrows and I can add the rest of my data here. I know that this assembly must be less than or equal to 600 total. This one must be less than or equal to 150 total. And this one must be less than or equal to 150 total. Yes, these less than or equal to signs don't actually do anything. They're just here as a text field. It's here to remind me which direction I'm going while I have solver open. Okay, so this is all the inputs that I need. This will get me to where I need to be. So let's actually run the solver now. So let's go to data. We're going to go to solver. Here's my solver. Okay, it defaults to GRG nonlinear when you open it. We don't need that. We're still in the linear programming, the LP, the simplex linear programming, which is what George Danzig came up with for us. So we can click on that because this is a truly linear problem. It's pretty straightforward. You can try any of the solving methods that you want, and if you're getting unusual results, you can come back and try a different one. But start with the simplex LP on this particular one. And in this case, I'm going to set my objective. I'm going to set it equal to this profit that I did up here. By changing the variable cells that I highlighted in yellow, okay, subject to the constraints, I'm going to add a constraint, and I'm going to say the cell reference that this total assembly time must be less than or equal to the constraint of 600. I'm going to click add. Then the constraint of trimmer time must be less than or equal to the constraint of 150. Click add. The shaper time must be less than or equal to the constraint of 150. I'm going to click add. Then I'm going to say that the standard size bookcases must be greater than or equal to 0. I'm going to add. Narrow bookcases must be greater than or equal to 0. I'm going to add that the wide bookcases must be greater than or equal to 0. I click OK. So now I have my objective in there, which is profit, my decision variables or changing variables cells, which is my array of quantities. And then I put all three of my constraints in here. I have my less than or equal to time and my greater than or equal to 0. I picked simplex LP, and if I click solve, okay, I'm going to keep the solver solution. And you can see here, just like what we had in the video, we came up with 150, 300, and 0 wide. We're not going to make any wide bookcases. We're focused on the other two. And sometimes when you come up with a solution like this and you're like, wow, we're really not going to make any of that one. It looks like it's $10 profit. It's the most profitable. Surely that should be part of our business decision. Apparently not. Apparently the cost of time is very high. It's too high on this one. So now we're going to play a little bit of what if and say, make a couple of changes here just to see some things. Use your brains, see if your model works. So when I was looking at this, I'm saying, wow, if I add a row down here, just out of curiosity, what is the sum of my handling time to make each of these items? So the standard bookcase is 1.2 hours, the narrow is 1, and the wide is 1.5 hours. Maybe this is the problem. So let's do a little what if. What if I improved my processes? So the trimmer only took 0.5 hours, and the shaper only took 0.4, and I get the total handling time for that wide bookcase down to 1.3. Let's do a little what if. Let's run our solver again with these changed assumptions. I'm not going to change anything else about the decision variables or the objective, and I'm going to click OK. Now, and in this case, it has me producing a bunch of wide bookcases because now my total cost and handling time is gone down, and I'm able to produce many. Now, some of you have already seen what has happened here. We've got kind of an interesting thing that has popped up. All of a sudden now, I'm making 272.7 bookcases. I don't know how to make 0.7 bookcases. Well, I might, but nobody's going to buy it. So I don't want to do that. Now, this is something that is later in the, I believe it's in chapter 10 or in chapter 11. But let's add some constraints here. Let's add a constraint. Okay. And we have a constraint of this cell reference. I'm going to highlight all three of these decision variables, and I am going to say that they must be an integer. Okay, that means they must be a whole number. I'm going to click OK. I'm going to run the solver again with no other changes besides that. Click OK, and you can see what it did is now it's got me making 270 bookcases that are wide. Okay, so it will only find a solution that does whole bookcases. Now, in this case, I went from making 0 narrows to 3 narrows. So in order to come up with whole numbers of bookcases, it says that I had to make these changes. Okay, now I'm going to change the constraints on the wide bookcase back to where they were, 0.6 and 0.5. And I'm going to change a different constraint. So one of the things that we saw here before is we're not using all of our assembly time because our trimmer and shaper time is running out of time before our assembly time does. So I'm going to claim that I've now added some more labor, and I can go up to 200 hours on my trimmer, and I can go up to 175 hours. No, let's make that 180 hours on my shaper, and let's run the solver again. Click solve. OK. All right, now we're back into the situation where the wide bookcases no longer make sense because I kept that handling time really high on the wide bookcases. The narrow and the standard predominate our production, but I want you to look here. We run out of trimmer time at 200 hours, and we run out of shaper time at 180 hours far before we run out of total assembly time of 600 hours. We're only using 232 hours of assembly time. This is the kind of scrutiny around a model that is the difference between somebody being an analyst and somebody being a business decision maker. If I looked at this, I would say, wow, I need well more than double the trimmer time and shaper time in order to make all of this doable. So let's just test another little hypothesis out. Let's play with this some more. Let's say that I bought a second trimmer and I bought a second shaper, and now I've got a lot more hours to play with, And on top of that, let's say that I marginally improved my trimmer time on the wide bookcase out of curiosity. Let's just see what kind of solution we get now. So I'm going to click Solve. No other changes. Oh, it couldn't find a feasible solution in this case. So let's glance at it. Why couldn't it find a feasible solution? Sometimes it's not readily obvious. Oh, I see why. I did something silly. Instead of changing the constraint values over here, I accidentally wiped out my formulas over here. So let me fix that. Let me change this to 400 and 360. Here we go. And now let's run solver again. And this is a great example. I did not make that mistake on purpose. Sometimes I'll do one on purpose just to show you what it does. In that case, I was just talking too much and thinking about something else, and I keyed into the wrong place in the spreadsheet. So I'm going to click Solve now. Okay. And now, with the much higher number of hours available and the slightly improved production time on the wide bookcase, our production becomes predominated by the wide. Okay. So playing with your model, finicking around with it makes a lot of sense so you can figure out things that you're doing. In this particular case, it might have been smart of me. So these are formulas that are designed to be my constraints, and these are data points that are my constraints. I might choose, if I'm going back and forth on this model a lot, to highlight one of those in a different color so that I make sure I go back to the correct one. And I come up with what a real constraint looks like. Now, for me personally, I'm curious, what if I go back to the 0.6 on the trimming time on the wide bookcase? But if I look at my total numbers here, it looks to me like I still have quite a bit of runway before I run out of assembly time compared to my shaping time and my trimmer time. So I'm going to change, and I'm going to go to triple in both cases. I'm going to say, what if I had 450 and 450 instead? And I put everything else back where it was, and I'm going to run this solver one more time. In this case, it's gone back to being predominated by standard and narrow, and we end up with a place where we're 9,000 profit, and again, we don't produce any wide bookcases, and we end up with this total. Okay, we could do some things in terms of calculating what our profitability is per hour. We can take a look at what the overall model looks like, but in general, we've ended up with a solution here that makes some sense. And I wish you all a lot of luck. I'm going to pull up that solver one more time so you can see what that looks like and let that linger here on the screen. You can see we constrained our bookcase quantities to all be greater than 0 and be whole number integers. We had our constraints that were relative to assembly time and machining time. And then we also had our decision variables and our objective variable. Every one of these problems is very similar to this. Don't make them more complicated than they need to be. I hope this has been helpful. Good luck.